Welcome back. We're going to finish up section 2.1. In this part, number 3, we're going to look at graphs of functions. A graph is just a picture of an equation. What it's taking is relating geometry to algebra. Algebra is the equation. Geometry shows us in picture format. When we graph functions, what we're really doing is using that rule. Remember, rule is what defines a function. So the input is x. Our output is what we plug into the function f of x. Just like when we're graphing y equals, let's say, mx plus b. Well, that's the graph of a line. X is the input. We plug that in, whatever m is, whatever b is, sum it up, or subtract as the case may be, and we get y, our output. But why do we graph? Equations are really nice and they're helpful, but most people are more visual, and it's a lot easier to see things, as we talked about in the last class period, trends in stock prices or trends in inventory levels or changes by a picture versus looking at just an equation. So let's continue on with an example. For an example, I chose, let's graph the function f of x equals the absolute value of x minus 1 plus 2. The first thing I ask myself when I look at a function is, do I recognize what the shape of that function is? In this case, I'm looking at, okay, absolute value. Now, yes, there's a minus 1 in there, and then there's a plus 2, but it's all going to be part of that family of functions which are absolute value. We know that the absolute value looks like a v. So when we get done with our graph, after we've come up with points and actually graphed it on the coordinate system, we should have something that looks in the shape of a V. If it's not in the shape of the V, obviously we've done something wrong. So that's a good point to just, if you recognize that u squared, oh, that's a parabola. If you graph it and it doesn't look like a parabola at the end, you've got a problem. The next thing I do is I set up a little grid with the values of x being my inputs, and then on the other side y, or in this case f of x, and I actually write out the entire equation. That way I don't have to keep looking back and forth, especially if there's more text in between you and where you're going to be writing, where you're actually going to be doing your calculations, so it's less easy to make a mistake. The first point I'm going to choose is something that's going to make x quote-unquote 0. In other words, I'm trying to figure out where the vertex, if there is a vertex, would be. You should hopefully remember back from your pre-calc class, if I plug in 1 into the equation, I'm going to have 1 minus 1, which is 0, so I've got the absolute value of 0, so I kind of have my 0 there, plus 2. So my first input and output is going to be 1 and 2. I know that the absolute value is a symmetric function. It's going to be symmetric around whatever that low or high point is going to happen to be. So I'm going to go for points on either side of the 1. So I'm going to look at 0 and 2. Now I know that their output should be the same. So if I plug in 0 into the equation, I'm going to get 0, the absolute value of 0 minus 1, which is going to give me 1 plus 2, and that gives me 3. Also, I can do that with 2. The best way to, when you're graphing, especially something that you know is symmetric, is to do 5 points total. So I continued stepping out. I went from 0, I also looked at negative 1 more further to the left, and I looked 1 further to the right. I looked at 3. And I did the calculations, and the outputs are the same, which is what I would expect. Now I need to draw my axes as we normally would. Notice that I definitely labeled the x and the y. That is critical. Inputs, outputs. You could have also said x and f of x, but usually we label it x and y. Input, output. I put in already some hash marks that correspond to the numbers I have. So then I'm going to now plot each of these points. So plotting the points and then connecting, drawing the lines. You notice with arrows heading out towards infinity, because obviously this function is just going to keep getting larger and larger as we go further out in either direction on x. It looks like a V, which is the shape I was expecting. And if you remember back from pre-calculus, it makes sense where it is. We expected it to be up 2, which it is, and we also expected it to be on the y-axis, I should say, up 2, and then on the x-axis, I expected it to be moved over 1 to the right. Just for a little extra practice, let's look at the domain and range. Looking at the domain, in other words, the inputs, there are no restrictions that exist. So we can say the domain is negative infinity to infinity. The range, as I go from negative, work my way up, go from negative, 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 negative. The first value I hit on the y-axis, because remember your range are your y values, is going to be at 2. And then we include that 2, and then it's going to keep getting larger and larger and larger, and it's going to go to infinity. Now, on an exam or during the homeworks, you do not have to give domain and range unless it's specifically asked for. The last topic in this section is piecewise defined functions. Piecewise defined functions are functions that have different formulas for different parts of the domain. Where students usually struggle is to figure out, well, what do I plug in and where do I plug it in? It's really crucial to use the appropriate formula given your input. I'll give an example to show how this works. So I came up with an example. We're going to graph f of x. F of x is the function, the rule, and it says it equals 5. 5 is the output for any input x less than or equal to 1. Now the output, negative 3, is only for when the inputs, your x's, are greater than 2. In this case, there are no calculations per se to come up with, you plug in an x, go through some algebra and pop out a y. Here, you're given them. Now, I know that my x's, I'll put a little x up here just to remind myself where my inputs are, and my y's are what is, in this case, 5 for x less than 1. So let's look at what I have for my inputs first. I have to look at inputs being 1 and specifically 2 is where there are restrictions. Restrictions begin and end. So let's take a peek. If x is less than or equal to 1, so specifically less than or equal to 1, my output is always going to be 5. Instead of counting up 5 hash marks, I would just put a line up there and a dash, and then put the number 5. And then I would put a closed circle at 1, and then I would draw a horizontal line through 5. That's all you have to do for the first one. You notice that 5, the output, is nowhere past 1 on the inputs. It would not be appropriate to draw the line, let's say, at 3, 5 to put a point, because the inputs for 5 are only when x is less than or equal to 1. So let's look at the second part of the statement. It says the output is negative 3, so I'll draw a negative 3 down here, for my inputs being greater than 2. So I'm actually going to have an open circle at 2 because I'm going to start at like 2.0000001, really, really, really close to 2, but not exactly at 2. And then my outputs are always going to be negative 3. Deceptively simple, but yet it's easy to, I've seen students a lot drawing 2 parallel lines, but you have to be careful. When can you use an output? It's based on your input. So let's do the domain and range for this. My domain are what my inputs are. So we can look at the graph, or you can look at what the equation gave us. Well, going from negative infinity, let's see, on my x-axis, I'm going to go to negative infinity, and I'm going to come in. My first stopping point is at 1. Now I'm going to include that because its x is less than or equal to 1. I'm going to use u. In other words, it also is going to include, well, the next point we hit is an open circle at 2, x equals 2. We're going to use a parenthesis for 2 because we don't include 2, and then we can just keep going to infinity. And remember, we can never get to infinity. Infinity is a construct. It's not an actual number. My range, now remember, there are 2 outputs. It's not appropriate to say, like, hard bracket -3 to 5 because it doesn't include anything between -3 and 5. This is, once again, we're going to use this notation, and we're going to put -3 as one output and 5 as the other output.